Hi and welcome to Note 2 of Nonlinear Resonance Video Notes. In this note I'd like to introduce you to the chaotic system, the nonlinear oscillator, I used for the neural network experiment and beyond, as mentioned in Note 1. I looked for a really simple system, but one with some features important in the more complicated and famous examples. Let's look at those features now. First, I wanted the system to be almost everywhere locally expanding. That is to say, if you have identical copies of the system and start up the first at almost any state and the second at a state nearby, that if the first, after one cycle, one iteration, the states of the two will be farther apart than they were initially. This situation isn't too hard to arrange. Consider ordinary biological growth, say a species and environment, where any populations will double each year. Starting a first population at 10,000 and a second population at 10,001, those are pretty close as the difference is just 1. After 1 year, though, the population difference will be 2, after 2 years, 4, after 3 years, 8, and so on, with the difference getting bigger each year. Second, I wanted the system to be bounded. That is, wherever you start the system within a particular restricted range, it will stay within that restricted range over time. Now this feature isn't true of the growth model, because in that model any population grows without bound. What happens in the real world is that there is some special population level, the carrying capacity. In the real world, populations that are bigger than the carrying capacity, rather than getting bigger by the next year, actually crash instead. The bigger the population is over the carrying capacity, the harder the fall. So, the feature I wanted was overshoot. If the population is close enough to the carrying capacity, it's sure to be over the line next year, and so crash the year after that. It turns out that it wasn't so hard to come up with a whole family of simple nonlinear systems with all three features, locally expanding, bounded, with overshoot. In the next node, we'll get to meet the family firsthand and play with a pretty ordinary member of the family and expose some family secrets.